Welcome to the DIY Honda Garage channel. The DTC P16BB indicates an issue with the alternator B terminal circuit low voltage in the Honda CR-V models post-2023. When the Powertrain Control Module, PCM, detects that the power supply voltage and the output from the alternator fall outside the specified range, it triggers this diagnostic trouble code. The PCM relies on these measurements for the efficient functioning of the vehicle's electrical systems. Understanding this DTC is crucial, as it may affect the stability and operation of the vehicle. An overview of the troubleshooting process will be provided next, detailing the components involved, their functions, and the steps needed to address the issue effectively. The components involved in the DTC P16BB include the Powertrain Control Module, PCM, and the alternator. The PCM is the vehicle's computer that manages various engine functions and ensures optimal performance by monitoring the vehicle's electrical systems. The alternator is responsible for charging the battery and providing power to the electrical systems while the engine is running. It converts mechanical energy into electrical energy through a rotating magnetic field. The alternator B terminal circuit specifically relates to the voltage output from the alternator, which, if low, can lead to electrical deficiencies. These components are usually located in the engine bay, with the alternator mounted on the engine block and the PCM located in a secure area away from heat and moisture. The potential causes for the DTC P16BB include several factors. First, a power supply voltage issue may arise if the battery is old, weak, or not fully charged, which can lower the voltage sent to the PCM and alternator. Second, a faulty alternator can directly impact the vehicle's ability to generate adequate power. If the alternator's internal components are degraded, it won't produce the necessary voltage. Lastly, loose or corroded connections in the wiring harness can disrupt the electrical signal and lead to low voltage readings at the B terminal. Thorough investigation of each of these areas is essential to pinpoint the exact issue related to this DTC. The symptoms associated with the DTC P16BB can manifest in several ways. Drivers may notice dashboard warning lights illuminating, particularly indicators related to the battery or charging system. Additionally, the vehicle's electrical systems may experience failures, which can include issues such as dimming lights or malfunctioning electronics. Another common symptom is a battery that drains quickly, especially if the vehicle is not starting or running properly. These symptoms indicate that the alternator is not supplying the necessary voltage, leading to a cascade of electrical issues in the vehicle that may necessitate further inspection and repair. The first troubleshooting step involves starting the engine and ensuring that specific conditions are met for accurate diagnostics. This includes turning on the air conditioning and setting the temperature control to maximum cool, which places additional demand on the alternator. Furthermore, the blower fan should be set to maximum speed, while the headlights are turned on high beam to maximize the load. In addition, the rear window defogger must be engaged to further stress the vehicle's electrical system. The engine should be held at 2,000 RPM without load during this verification, either in park or neutral for 1 minute. This step is crucial for simulating high electrical load conditions and helps to determine if the alternator can adequately sustain voltage levels under stress. For the second troubleshooting step, the ACG plus B circuit must be inspected, focusing on the alternator B terminal. Disconnect the alternator B terminal to conduct this inspection safely. In the ignition mode, verify the normal conditions for the ACG plus B circuit should reflect a battery voltage of approximately 12 volts. If the measured voltage is outside this normal threshold, it indicates a fault within the circuit itself. and abnormally low voltage could suggest a power supply issue emanating from either the battery or corroded connections. Therefore, careful evaluation of the circuit integrity and continuity is essential in identifying any wiring issues that may lead to this DTC detection. The next step involves checking the connections at several key locations, including the alternator B terminal, the alternator itself, and the fuse holder associated with the ACG_+B line. Visually inspect these connections for any signs of corrosion, loosening, or physical damage. Secure connections are critical for maintaining proper voltage levels, as loose or damaged terminals can lead to intermittent electrical failures. Ensure that all connectors are firmly seated and that there are no frayed wires. Additionally, conduct a thorough inspection to confirm that the fuse holder for the ACG_B line is intact and free from any electrical faults. This step methodically addresses the physical and visual aspects of connectivity that could contribute to low voltage readings. In the final troubleshooting step, focus on conducting a comprehensive inspection of the alternator itself. After confirming that all other connections and circuits are functioning correctly, it is reasonable to infer that the alternator may be at fault. Testing the alternator's output can help you determine if it is functioning at a normal capacity and producing adequate voltage. If the output readings are far below the expected threshold, it may indicate internal failure within the alternator. This could involve issues with the diodes, voltage regulator, or winding within the alternator, which would prevent it from efficiently converting mechanical energy to electrical energy. Therefore, a definitive diagnosis can guide whether the alternator needs repair or replacement. After completing the necessary repairs or replacements based on the diagnostics for DTC P16BB, it's essential to carry out a final verification process. This involves rechecking the voltage levels at the alternator B terminal to ensure they are within the specified range. Confirm that all the previously inspected circuits and connections are intact and functioning correctly post-repair. Running the engine under the same load conditions as before may also be advisable to verify that the alternator can maintain proper voltage. Monitoring the vehicle for any symptoms previously encountered will further establish whether the issue is resolved. A thorough review of repairs helps ensure that the solution is both effective and sustainable. While specific preventive maintenance for DTC P16BB wasn't mentioned in the provided text, general practices apply to prevent similar issues. Regular inspection of the alternator and its connections should be part of routine vehicle maintenance. Keeping the battery terminals clean and free from corrosion can prevent electrical resistance and ensure consistent voltage output. Furthermore, it's advisable to periodically check the integrity of all wiring harnesses related to the charging system. Any signs of wear, fraying, or damage should be addressed promptly to avoid complications. Routine battery testing can also help to confirm its health, thereby preventing low voltage issues that may affect the PCM and alternator performance. In conclusion, addressing DTC P16BB requires a systematic approach to identifying electrical issues within the alternator and associated circuits. Key diagnostic steps include evaluating the PCM's voltage readings, inspecting the ACG+B circuit, and checking connectivity at connector points. A careful inspection of the alternator itself is crucial if other components are functioning correctly. Regular maintenance practices can help prevent similar issues in the future, ensuring optimal alternator performance and overall vehicle reliability. Understanding this trouble code allows technicians and vehicle owners to act promptly, enhancing the longevity and functionality of the Honda CR-V's electrical systems. Please like and subscribe to the channel. See you next time.